Hey guys, Buildzoid here, and we're back with the 12600KF on the MSI Z690 Torpedo EKX motherboard. It's running Prime 95 again, and it's running it at slightly higher frequencies than last time. It's been running it for the last 2 hours and 18 minutes. And the reason it is now stable at slightly higher frequencies than last time is because it has a new cooling system. It is no longer on a test bench, it is now actually inside a case. Now, fun fact, I've built multiple custom loops. I've never built one in a case before. This is the first time I've put a custom loop inside an actual case, and I did not like it was interesting because the whole difficulty of you put the radiator inside and then it's like, wait a minute, where does the pump go? Anyway, I did eventually figure that out, and yes, the cable management is terrible. Luckily, cable management doesn't affect CPU temperatures or CPU performance, so as long as you don't look at it, it's like it's not even there. Anyway, yeah, so this is the setup and the loop that I'm using. I guess, yeah, let's go over the loop first and also the case. So the loop, the loop I'm using is the EK Classic Kit P360. This was obviously sent to me by EK specifically so that I could compare like a proper CPU block against against the mono block. There, I finally remembered what it's called. Yeah, so the kit has absolutely everything you need. There's no extra parts in this than, the two fans are not from the kit, but, like, pump, reservoir, fittings, the angle fittings, all of that just comes in the kit, so that was really neat. Especially the angle fittings, like, that was... Because, yeah, like, when I was putting this in, I didn't initially realize that the kit came with angle fittings, and so when I was trying to figure out where to put the pump, I was, like, really concerned about what I'd have to do with the tubing in order to get it to reach. I guess I could have done, like, a crazy loop thing that would have worked out, somehow. But, yeah, no, EK does include two 90-degree fittings in that kit, and so I didn't have to do anything really horrible with the tubing length in order to get everything to hook up. Yeah, anyway, so the loop order is basically the pump goes straight to the CPU block, and then the CPU block goes to the radiator, and then the radiator goes back to the reservoir. And yeah, so that's the loop. And then I'm just using the fans that the kit came with for the radiator. Anyway, the case that I've put this in is a Carbide Series 400C from Corsair, which wasn't provided by Corsair. I bought this case like ages ago because it's got a door. It's not super expensive. It looks pretty generic, right? It has like the closed off front panel with the side vents. So this was sort of the VRM, the main reason I bought this case back in the day was like to do VRM thermal testing inside an actual case instead of just on an open air test bench, because most people don't run their motherboards on open air test benches. And at the time, I wasn't really concerned about, water cooling or anything like that. The whole compact part didn't really hit me until I built the custom loop. So, yeah, but everything worked out well, I think. I mean, the cable management's horrible, but the loop fits well, it performs well, and that's the only part I really care about. Anyway, so... yeah, back to the Prime 95 run here. So it's been running Prime 95 for the last 2 hours, 20 minutes. It's running at 5.075 gigahertz on the P cores and 4.16 gigahertz on the E cores. So evidently, when I was doing the AIO, when I was doing the overclock on the AIO, the E cores were evidently like right on the edge of not doing 4.1 gigahertz. And this is right on the edge of not doing 5.1 on the P cores. Yeah, like the 5075, like technically I've had successful, like it'll do a few minutes at 5.1 with the current voltage settings, but yeah, it won't do like 2 hours and 20 minutes. So that's why it's at 5075, but I think there's a decent chance that the monoblock, which is supposed to have even better CPU cooling performance than just like this custom loop, or more like the EK Supremacy Classic block has. Like, the cooling improvement to the CPU alone might be enough to get this from 5075 to 5100. So, yeah, on the P cores. I'm not sure if it'll also help the E cores that much, but I guess we could, like, if the temperature comes down, I can just bump up the voltage again, because that's how this was set up. Anyway, so yeah, the P cores are doing almost E cores are doing almost 4.2, and the ring clock is also slightly higher at 4.26 gigahertz. So all around, it's just faster than the AIO setup, and this is still on conventional thermal paste. This isn't like liquid metal or anything. It's just Arctic MX4. And so, yeah, I'm really pleased with the result here. Now, the ambient air temperature is a little bit lower. It's like 19 degrees Celsius instead of like 21 degrees Celsius when I did the AIO testing, but honestly, that doesn't make that much of a difference. On the AIO, the CPU was set up to pull around 250 watts of power. Now we can get away with around 270, while still having, like pretty similar temperatures ultimately. So yeah, the custom loop doesn't really change the max power limit that much. And I mean, it's not power limited, but this is like as much power as I can cool with the current configuration, right? Anyway, yeah, our load voltage isn't that much higher. It's just 1.238 volts, whereas previously it was like 1.206. So it's about like 30 millivolts more core voltage, and that's basically where most of the stability improvement comes from. So yeah, so this has been just happily running Prime 95 for now, and I guess I guess we should point out the VRM temperature settings. So this is why I'm really glad that I decided to do this inside an actual case and not on a open air test bench, because the thing with open air test bench VRM testing is like, it doesn't tend to be particularly, like, it's nice as a torture test. Like, if it doesn't overheat on an open air test bench, there's probably no way it's ever going to overheat. But yeah, on the open air test bench with the AIO, it was getting around like 200. What was it? No, it was getting around 80 degrees, 82 degrees Celsius max VRM temperature. Inside the case, it's only getting like 67 degrees Celsius. And this is still with the switching frequency of the VRM just completely maxed out to really maximize the VRM heat output, because yeah, the 12, like, honestly, I'm starting to think I really might have to test this with the 12900K, because this is running this is running really cool, which kind of makes sense. I mean, we've got three 360 millimeter fans intaking air, and the thing is, the CPU isn't dumping so much heat into the radiator that the air temperature inside the case should be that high. But yeah, like 67 degrees, like that's a very, very good VRM temperature, which also isn't that surprising. Like, the VRM on this board is actually like very substantial. So yeah, it'll be, I guess once we switch over to the mono block, it'll be at like 40 something. So that's great. And it'll probably be at like 40 degrees Celsius, like 40 something, even with even higher power consumption, because I'm really hoping that the mono block improves the CPU cooling, because I've been told that it should. So yeah. Anyway, I guess let's take a quick look at the BIOS settings. Oh, I wanted to run Cinebench. We can do that after taking a look at the BIOS settings, because, like, Cinebench, just to give you an idea of the CPU performance, the memory's not, well, okay, no, the memory is technically overclocked because I raised the BCLK. Wrong keyboard. Now we're going to find out if we get the BIOS or Cinebench. Okay, we got BIOS. Okay, so, yeah, 50 on the P cores, 41 on the E cores, 42 on the ring, 101.75. So this motherboard doesn't have an external clock gen, but the K CPUs have a unlocked clock gen built directly into them. The one downside to it is it's not particularly granular. As you can see, it doesn't go in like 0.1 megahertz increments or 0.01 megahertz increments. It goes in like 20-ish something. I'm also not sure where it tops out. It can go really high, evidently. But we're going to go back down to that 0. Actually, I could just not save the settings, but yeah. So 101.75, and there's no problem with raising the BCLK on 12th gen CPUs. The BCLK only affects your ring, core, and memory speeds. It doesn't affect like PCIe or SATA or USB ports or anything like that. So you don't have to worry about that. The memory is just at stock. The core voltage is all the way at 1.42 volts. That is perfectly safe to use because we have mode 5 LLC, so, on full load at the highest temperatures, it's well below like 1.3 volts under load. And then for idle, it actually doesn't even really reach 1.4 volts either because there's just so much V-droop to go around. And you want a decent amount of V-droop because it helps you, basically it helps with transient response for the VRM. The VRM basically doesn't have to fight the CPU so hard during load transitions. Because, fun fact, the CPU does not request a increase in current. It just kind of grabs it, and the VRM has to deal with that. So that's why we have V-droop. Anyway, VRM switching frequency completely maxed out. I've still not got, like, the thing is, I'm going to be hooking up the motherboard to the oscilloscope probably... I should do that before I do the PCB analysis. So I'll do that before the PCB analysis, but that'll be like second to last piece of content that I'm doing with it. For now, I don't know if maxing out the switching frequency on this motherboard achieves anything in terms of voltage regulation. It probably doesn't. The board does use a high-end monolithic power systems voltage controller, so I would imagine that this setting really just increases VRM heat output without actually achieving much of anything. But considering that, the goal of a lot of this testing is to see how effective the monoblock is at cooling the VRM, I'm running the switching frequency maxed out even if there's no practical benefit to that because it gives me more VRM heat to deal with when we switch over to the monoblock. Though it could potentially also help with the voltage regulation, though, again, I'd need to check with the oscilloscope, because a lot of the time the switching frequency will make, on motherboards where it does make a difference, the difference is very minor, actually, I've not found a motherboard where it makes a major difference. On most high-end motherboards, it doesn't do anything. On some low-end motherboards, it helps a little bit, but I've also not tested, the thing is, I feel like if you had a motherboard which was so terrible that the switching frequency made a major difference, it would also be so terrible that it wouldn't be worth it. It just wouldn't, it'd be like, yeah, if you raise the switching frequency, it becomes slightly less, it becomes significantly less awful, but that doesn't change the fact that it's still awful. And I've not run into a motherboard like that yet. Anyway, I've also raised the CPU PLL voltage to 1.095 volts. This is perfectly safe for long-term use and slightly helps with stabilizing high CPU overclocks. And then the ring PLL voltage is also slightly raised, which can help with ring overclocking. So, yeah, that's kind of that for the CPU settings. And, oh, wait, actually, this is something I did forget to do in the previous video. So AVX is enabled. So AVX 256 is enabled. There's no downclocking for AVX instructions because having your CPU randomly downclock, in my opinion, is a dumb thing. We have power, so the power limits are, actually, I forgot where it's set, right. So MSI handles the power limits has this really convenient setting for just maxing out all the power limits, so that's just set to water cooler. Then for the CPU over temperature, I actually raised that a bit. I wouldn't do that. Honestly, I shouldn't, at this point. This was for when I was first figuring out, the settings for the CPU, and it's just kind of been left over from that. So at this point, it actually would be a good idea to lower that back down to something sane, like 102 degrees Celsius. Yeah, actually, the BIOS straight up gives you a warning if you set it too high, so... Yeah, if you set it over 105, so we're just gonna... we're gonna set it to 102. There. It didn't hit 102 degrees Celsius during that entire 2-hour, 20-minute run of Prime 95, so I'd set it to 102. Anyway, that's kind of that. Yeah, so that's all the CPU settings. I'm kind of toying with the idea of maybe also throwing a memory overclock at this point. Could be kind of, if I had any modern GPUs, it would be kind of fun to do, a full system overclock, CPU overclock, GPU overclock, memory, everything dialed in. Unfortunately, I don't have any modern GPUs, unless you count 1080 Ti's. So, yeah, anyway, we're just gonna save and reset at this point. And then run some Cinebench to show you what kind of performance we get. And it is pretty quick at this point. At low loads, the system is entirely too quiet. The fan curves, it's just on the default fan curves from the MSI BIOS, and at idle, it is entirely too quiet. I was kind of worried it wasn't running anymore. Anyway. Or more like I wasn't sure if it was actually restarting just then. I'm not sure why I'm pulling up hardware. Oh, well, it'll give you some idea of how much cooler Cinebench runs compared to Prime 95 at the very least. So Prime 95 was, peaking at like 100 degrees and was basically constantly above 90. As you can see, Cinebench sits at around 82 degrees. Now, admittedly, the cooling loop has probably cooled down a bit at this point. Yeah, so Cinebench runs a lot cooler than Prime 95 does, which is what you'd expect. And we can also check the idle voltage in the OS right now. And that gets us a score of slightly over 7,600 points, which actually, yeah, not bad. For a 6-core with 4 dead weights attached to it. Actually, for Cinebench, Cinebench is the one, one of the. Okay, I'm not sure how few the workloads are that really benefit from the E-cores, but Cinebench really likes the E-cores. There's other workloads that absolutely hate the E-cores. Mostly because the E-cores seem to cause some kind of congestion on the memory system of the CPU. And so anything that's really memory intensive just starts tripping over itself if you have the E-cores turned on, which is really annoying. Anyway, 7663. Yeah, so Cinebench not super so fun fact about Cinebench R20, and I think all of the Cinebench tests, it tends to go up if you rerun it a few times. Anyway, so our idle voltage right now is 1.37 volts, and yeah, I'd have no problem with that's perfectly safe for long-term use. This is the thing is yes, the voltage setting I have in the BIOS looks relatively high at 1.42 volts, which I still wouldn't consider an unsafe voltage for a 12th gen CPU. But then once we're actually in Windows and even, if I close Cinebench, it's not going to change anything. The CPU is currently using a 0% CPU load. Okay, 3% CPU load, right? And we're not even close. We're not even close to 1.4 volts right now. So yeah, this is perfectly safe for long-term use. It's very stable. In fact, if I was potentially thinking about this as a daily setup, I would probably opt for less. I wouldn't prioritize the Prime 95 stability. The thing is, in this case, Prime 95 is a really good way to test VRM capabilities and cooling capabilities because it pulls insane amounts of current at the lowest voltages compared to any other workload. There's nothing that is as heavy as Prime 95 small FFTs because Prime 95 small FFTs runs entirely out of the CPU's L3 cache, whereas most other workloads will, access the memory at least a little bit. And so they can't quite achieve the same level of CPU core utilization because anytime you're accessing the memory, well, you're waiting for memory access. You're not, burning the CPU down with AVX instructions. Well, yeah, so potentially, honestly, you could retune this on this level of voltage, but for a different stress test, say LinPack or I don't know, some people like OCCT. I wouldn't really go with anything less than LinPack. Cinebench is not a stress test. I guess you could tune for Y-Cruncher. That would be a good one. So yeah, there's other stress tests you could target with your stability testing instead of Prime 95, but if you need absolute 100% reliability, Prime 95 small FFTs is it. There is nothing that hits the CPU as hard for 12th gen CPUs. For other CPUs, there are some exceptions to that, Ryzen 5000, if you have good memory settings, does some crazy things in LinPack. But yeah, for Intel 12th gen CPUs, Prime 95 small FFTs with AVX 256 instructions, specifically AVX 256 instructions, is as hot as it gets. So, yeah, anyway, I'm really kind of, for one thing, I'm not surprised, but I am pleased that the switch to the AIO to the custom loop actually led to slightly higher CPU clocks, right? We've got, higher E-core, like the E-cores are actually clocked significantly higher, but I really think that's because on the previous cooling system, I wasn't quite able to stabilize 4.1. And so if, like, the thing is, I wouldn't prioritize the E-core frequency in any kind of 12th gen tuning situation. You want to prioritize the P-cores first, then worry, like, if you're going to keep the E-cores turned on, then worry about the E-cores. And so the E-cores in the previous configuration, well, they wouldn't run 4.1, even though they probably could have run like 4.08 or something. Because, yeah, 4.1 was really borderline. Like, it would almost pass at 4.1. And so now that, I have slightly more cooling, slightly more voltage, they can do 4160 because previously they were right on the edge of not doing 4.1. So I wouldn't count this as like all the E-cores picked up 162 megahertz. It's just that this configuration allows them to be at a like they don't have to be at like 4.2. They can be slightly below that, and they're perfectly happy with that. So yeah, and then the P cores are at just under sort of 5.1. And the ring picked up a little bit, and so yeah, custom loops are worth it. Well, I'd say it's worth it. Like, honestly, the EKK, I mean, oops, forgot which thing I want to change. But like, I don't think this, like, there are AIOs that are like approaching this price point, and they're not going to be as good. Because the thing with custom loops is you have higher water flow rates because they use stronger pumps than what you get in AIOs. You get thicker radiators made out of copper, so you have more surface area, so more cooling capacity. And also the water blocks, I suspect, are somewhat better than what you get in Asetek AIOs, at least. I'm not sure about the Arctic AIOs. Those might actually be competitive with custom loops, but the Asetek blocks, I have a sneaking suspicion, aren't actually that great compared to what you get in custom loops. So, yeah. That's kind of it for this configuration of the 12600 KF, and hopefully this is somewhat helpful if you're, overclocking a 12th gen CPU on an MSI motherboard. And in the next installment, we will have the mono block on there, and I guess the VRM is going to be like ice cold, and hopefully I'll be able to push the CPU a little bit further again. So we shall see. Anyway, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it'd be much appreciated if you check them out. And that's it for the video, so thank you for watching, and goodbye.